Now there may be some questions where we need to find mirror image of a parabola about certain line. Say for example, we need to find mirror image of the parabola y square equals 4x in a tangent to this parabola at 1, 2. So we'll draw this parabola. Now we'll take a point which is at 1, 2 and we'll draw a tangent at 1, 2. Now we need to find equation of parabola which is mirror image of this parabola about this tangent. So we need to find equation of parabola which is mirror image about this tangent. Now we know that equation of tangent when the point lies on the curve is given by t equals 0. So we can write this equation as 2y equal to 4 x plus 1 by 2. So 2 and 2 will cancel. So equation of this tangent will be x minus y plus 1 equals to 0. Now we need to find equation of this parabola. So any point on this given parabola, we can write it as at square 2at, and reflection of this point about this line will lie on this parabola and say it is alpha comma beta. These alpha and beta, they are mirror image about this line x minus y plus 1 equals to 0. So we can write this as alpha minus at square upon 1 equals beta minus 2at upon minus 1, and this is equal to minus 2. We'll put the value of x and y. So it will be at square minus 2at plus 1 upon a square plus b square, which is simply 2. So we'll get this alpha as, now at square, here it will cancel and we'll get it as 2at minus 1, and if we write beta, we write beta minus 2at, and here it will be at square minus 2at plus 1, so it'll also cancel. So we'll get alpha plus 1 equals 2at and beta minus 1 equals at square. Now we'll eliminate t from these two equations. We know that this is y square equals 4ax. So we can write this as alpha plus 1 whole square equals 4a, and x here is beta minus 1. Now for this parabola, value of a is 1. So this locus will be x plus 1 square equals to 4y minus 1. So mirror image of y square equals 4x in the tangent to parabola at 1, 2 is x plus 1 square equals 4y minus 1. Now we'll take another reflection problem. Then it says if the reflection of the parabola y square equals 4x minus 1 in the line x plus y equals 2 is a curve ax plus by equals x square, then we need to find the value of a plus b. So we are given this parabola which is y square equals 4x minus 1. So we'll draw this parabola. So it is y square equals to 4x but shifted 1 unit to the right. And then we are given equation of this line which is x plus y equals 2. Now it says reflection of this parabola about this line is this curve which is ax plus by equals x square. So reflection of this parabola about this line is this parabola which is ax plus by equals x square, and we need to find the value of a and b. Now in this question we need not even find image of a point. So what we know is from this given equation and this given line we can find their point of intersections. So we can write y square equals 4. Now we can write x minus 1 as 1 minus y. So it will be 4 1 minus y. So it will be y square plus 4y minus 4 equals to 0. So it will be plus 4 minus 4. So y plus 2 whole square equals 8. So it will be y equals minus 2 plus minus 2 root 2. So one of the point of intersection is y equals minus 2 minus 2 root 2, and another one will be y equals minus 2 plus 2 root 2. Now we'll put the value of y in this equation and then we'll write the value of x. So here value of x will be 2 minus y. So it will be 2 plus 2, 4 plus 2 root 2, and here it will be 4 minus 2 root 2. So we have these 2 points of intersections. So this point is 4 minus 2 root 2 comma 2 root 2 minus 2, and this point of intersection is 4 plus 2 root 2, and this is minus 2 minus 2 root 2. Now this reflected parabola will also pass through these point of intersections. So we'll put the value of x and y. So we'll put the value of x and y. We'll write a, and this is 4 minus 2 root 2 plus b minus 2 plus 2 root 2, and this is equal to x square, which is 4 minus 2 root 2 square. So we can write this as 4a minus 2b and then plus minus a plus b 2 root 2, and it will be equal to, now this is 16 plus 8, so it will be 24 and then minus 16 root 2. We'll compare rational parts and irrational parts. So we'll compare rational parts, then we can write 2a minus b, and it is 12, and we'll compare this irrational part. We'll get a minus b, and it will be equal to 8. So we'll subtract, we'll get the value of a as 4, and if a is 4, value of b is minus 4. So the value of a plus b is simply 0. Now let us take very interesting rolling parabolas problem. Now the question is, the parabola x square equals 12y, which means this parabola, it rolls without slipping around the parabola x square equals minus 12y. So this parabola, it is fixed, and this parabola on the top, it is rolling without slipping around this second parabola. We need to find locus of focus of rolling parabola, and also we need to find locus of vertex of rolling parabola. Now these two parabolas, they are mirror image of each other about x-axis. So if we'll consider any point on this parabola, which is x square equals 12y, and say this point is a, and any parametric coordinate, it is 280 comma 80 square for this third form, and here in this case value of a is 3, so it will be 280, so it will be 6t comma 3t square. So if this parabola, it starts to roll along this fixed parabola, then it will cover the same distance because it rolls without slipping. So that means if it covers the same distance, then once this parabola, it rolls down, then in that case this point a will come to this a dash, whose coordinate will be 6t comma minus 3 square. So basically now we can draw this parabola in this way. Now we need to find locus of its vertex and focus. Now clearly we can say that this parabola, once it has rolled down along this fixed parabola, it is nothing but it is reflection of this fixed parabola about tangent at this point A. Now we'll start solving the question. Now the first question, find the locus of focus of rolling parabola. Now focus of rolling parabola will be mirror image of focus of this fixed parabola, and focus of this fixed parabola is 0 comma minus 3. Now in one of the previous videos, we have already established this property that image of focus about any tangent to parabola will lie on directrix. So image of focus about any general tangent will always lie on directrix of parabola. So for this rolling parabola, its focus will lie on directrix of this fixed parabola. So which is y equals 3. So answer to this first question is locus of focus of rolling parabola will be along this line, and that is y equals 3. So this first part, it is very simple. Now we'll come to the second part. Now second part says we need to find locus of vertex of rolling parabola. Now vertex of rolling parabola, it is mirror image of vertex of this parabola about this tangent. Now once we have this point and we have equation of this parabola, we can write equation of this tangent. So equation of this tangent is given by t equals 0. So in place of x square, we'll write x into x1. So it will be 6t into x and then minus 12. And in place of y, we'll write y plus y1 upon 2. So it will be y minus 3t square upon 2. So now here 6 and 6, it will cancel. We can write this equation as tx minus y plus 3t square. So equation of this tangent, which is t equals to 0, is given by tx plus y minus 3t square equals 0. Now we need to take reflection of vertex for this fixed parabola, and that is 0, 0 about this line, and it will give us the locus of vertex of rolling parabola. Now say this vertex is alpha, beta. So now we'll use formula for reflection. So we'll reflect origin about this line, then we can write alpha minus 0 upon t equals beta minus 0 upon 1, and this is minus 2. If we'll put x and y as 0, so it will be 0 plus 0 minus 3t square upon 1 plus t square. So we can write alpha as 6t cube upon 1 plus t square, and we can write beta as 6t square upon 1 plus t square. Now we'll need to eliminate t from these two expressions. So what we'll do is we'll divide first by second. So then we can write alpha upon beta, and here 6 will cancel, 1 plus t square will cancel, and t square will also cancel. So we'll get alpha upon beta as t. Now we'll put the value of t in this second equation. Then we can write beta equals 6 alpha square upon beta square, and here it will be beta square plus alpha square upon beta square. So it will cancel. So we can write this equation as beta into beta square plus alpha square minus 6 alpha square equals 0. Now in the end, we'll replace alpha with x and beta with y. So we'll get this locus as y into x square plus y square minus 6x square equals 0. And that is the locus of vertex of this rolling parabola. Now this is an interesting question involving complex numbers and parabola. It says, let z be a complex number of maximum amplitude satisfying mod of z minus 3 is equal to real part of z. Then we need to find the value of mod z minus 3. So first we'll simplify this equation. So what I'll do is I'll let z as x plus iota y. So then we can write x minus 3 plus iota y is equal to real part of z, which is x. So we'll find its magnitude and we'll square it. So we'll write x minus 3 square plus y square is equal to x square. So we'll get x square plus 9 minus 6x plus y square is equal to x square, which will get cancelled. So we'll write y square equals 6x minus 9, or y square is 6 and then x minus 3 by 2. If we'll compare it with the standard parabola, then will be y square equals 4a capital X. Now in this case, value of a is simply 3 by 2. So we have this parabola whose vertex is at 3 by 2 comma 0. So we'll draw this parabola. Now on this parabola, we need a point Z having maximum amplitude. We know that amplitude is nothing but angle that a point makes with positive real axis. So if we look at these points, then we know that this angle, it is increasing. Then we'll have one point where this argument will be maximum. So this argument will be maximum at a point P at which tangent drawn will pass through origin. So we'll need to find coordinate of this point P. So once we have equation of this parabola, we can write equation of tangent as y equals m. Now in place of x, we can write x minus 3 by 2 and then plus a by m. Now a in this case is 3, so it will be 3 by 2m. We need that tangent which passes through origin. So we'll put x and y as 0. So we'll put x and y as 0. We'll get 0 equals minus 3m by 2 plus 3 by 2m. So from here we'll get the value of m as plus or minus 1. Now since we need z of maximum amplitude, we'll take m as plus 1. So for this z, value of m is plus 1. Now once we have this slope, we can write this point of contact. So this point of contact will be x equals a by m square. Now x in this case is x minus 3 by 2 and it should be equal to a by m square and then y equals 2a by m. Now we'll put the value of a and m. Now a is 3 by 2 and m is 1. So we'll get x as 3 and y as 3. So this point P, its coordinate will be 3 comma 3 and this z is 3 plus 3 iota. Now we'll need to find the value of mod z minus 3. So mod z minus 3, it will simply be mod of 3 iota and mod of 3 iota is 3. So answer to this question is 3. Now here the question is, let z be a complex number satisfying this equation, which is mod of z minus 2 is equal to real part of z. Then we'll need to find minimum value of mod z minus 4. Now we are given that mod of z minus 2 is equal to real part of z. So we'll take z as x plus iota y. Now we can write this as mod of x minus 2 plus iota y and real part of z, it is simply x. So it will be under root of x minus 2 square plus y square equals x. So we can write x square plus 4 minus 4x plus y square equals x square. So we write this equation as y square equals 4 x minus 1. So basically z lies on this parabola whose focus is at 1 comma 0. So we'll draw this parabola. It says we'll need to find minimum value of mod z minus 4. So in complex numbers, we know that modulus is basically distance between 2 points. So one of the point is z, which lies on this parabola, and another point is 4, which lies on axis of this parabola. So we need to find the minimum value of this distance between a point on parabola and this fixed point. Now we have already studied that minimum distance will occur along a normal which will pass through this point. So what we'll do is, for this parabola, we'll write equation of normal. So for this parabola, equation of normal will be y equals m. Now in place of x, we'll write x minus 1 minus am cube. A in this case is 1. So it will be m cube minus 2m. We need that normal which passes through this point 4, 0. So we'll put y as 0 and x as 4. So it will be 0. And then 3m minus m cube minus 2m. So it will be m cube minus m equals to 0. We'll get three values of m. Either m is 0 or m is 1 or m is minus 1. Now three normals can be drawn from this point 4, 0. We need to find shortest distance from this parabola. So we'll write foot of all the three normals. So we know that foot of normals is given by am square minus 2am for a parabola which is y square equals 4ax. But we have a parabola which is y square equals 4x minus 1. So in this case, foot of normal will be given by 1 plus am square minus 2am. Now for this parabola, value of a is 1. So now we'll start putting the value of a and we'll start putting in the value of m. So we'll take m as 0. We'll get this point as, say, a, and it will be simply 1, 0. If we'll put m as 1, then we'll get this point, say, b. So a is 1 and m is 1. So it will be 2, minus 2. So b is 2, minus 2. And then we'll find this point which is c when the value of m is minus 1. So we'll put m as minus 1, we'll get this point c as 2, 2. So this point, it will be 2, 2. Now we'll find all these three distances and then we'll see which is the minimum distance, and there will be the minimum value of mod z minus 4. So we'll find this AP. So this AP is simply 4 minus 1 and that is 3. And from symmetry we can say that BP must be equal to CP. And this value, it will be under root of 2 square plus 2 square, and that should be 2 root 2. So the minimum value of mod z minus 4 will be simply 2 root 2. And that is the answer to this question. Now this third question is, we are given a set which is sigma, which is set of all complex numbers x plus iota y such that mod y is less than or equal to 1. And then we are given this function which is fz, and that is z square plus 2. Now it says, draw a sketch of f sigma which is fz for all z belongs to sigma. So that means for all the complex numbers z present in this set, we need to draw the sketch of fz. Now first we'll look at input values. Now this sigma, it contains all the values of x and y such that mod y is less than or equal to 1. So when mod y is less than or equal to 1, it means value of y should lie between minus 1 and plus 1. So its domain spaces within these two lines, which are y equals 1 and y equals minus 1. So we are talking about all the points in this shaded region. Now we'll put the points from domain in this function, then it will transform into an output space. Suppose u plus iota v. So we'll write this fz as sum u plus iota v, and it is z square. Z is x plus iota y whole square plus 2. So we'll write this as u plus iota v, and it'll be x square minus y square plus 2 xy iota. Now we need to draw sketch of u and v. Now comparing real and imaginary part, we can write u as x square minus y square plus 2, and we'll write v as 2xy. Now the condition given in the question is this mod of y is less than or equal to 1. Now what we'll do is we'll begin with the boundary cases. The boundary cases which are when the value of y is 1, when the value of y is minus 1, also when the value of y is 0. So when the value of y is 1, in that case, u will be x square plus 1 and v, it will be 2x. So we can write this x as v by 2. So we'll write this as v square by 4 plus 1. So we'll get this parabola which is v square equals 4u minus 1. So we'll take this boundary condition when the value of y is 1. We'll end up getting this parabola which is 4u minus 1. Now we'll take y as minus 1. If we'll take y as minus 1, again we'll get u as x square plus 1 and v is minus 2x. Again we'll replace x with minus v by 2. So we'll get u equals v square by 4 plus 1. So again we'll get v square equals 4u minus 1. So that is for both the boundary values 1 and minus 1, we are getting the same parabola which is v square equals 4u minus 1. Now if we'll put y as 0, in that case we'll get u as x square plus 2 and v as 0. In that case we'll get a ray lying on x-axis and which is greater than or equal to 2. Its y coordinate will be 0. Now what we'll do is we'll plot these 3 sketches. Now this is u and this is v. Now this is y square equals 4ax. So it represents a parabola opening rightwards and shifted 1 units to the right. So we can draw this parabola as v square equals 4 into u minus 1. Now second one, it's again the same parabola. And this third one is u equals x square plus 2. So in this case, u will be greater than or equal to 2 and v is 0. So we'll represent this ray starting from 2 and going towards infinity. So this is the sketch of boundary values. Now we need to find this complete region. Now we know that this u is x square minus y square plus 2 and v is 2xy. So we'll square the second equation. We'll get v square equals 4x square y square. Now in the question it says mod of y is less than equal to 1, which simply means y square is less than equal to 1. So we can write v square is less than or equal to 4x square. Now from this first equation we can write y square, it is x square plus 2 minus u, and again it is less than or equal to 1. So from here we'll write x square is less than or equal to u minus 1. So now we have two inequality relationships, which is v square is less than equal to 4x square and x square is less than u minus 1. So from these two we'll get this condition which is v square is less than or equal to 4 u minus 1. So that means for all the points in this input space, we are getting a condition where v square should be less than or equal to 4 u minus 1. So if we'll take any point, say origin, if we'll put v as 0 and u as 0, we'll get 0 is less than equal to minus 4, which is incorrect. So that means we are talking about region other than origin. So the sketch of output space is this parabola and points lying inside of this parabola. And that is the answer to this question. Now the next result is, if the tangents at P and Q meet in T, then TP and TQ subtends equal angles at focus S, and we'll also need to show that ST square equals SP into SQ, and these triangles SPT and STQ are similar. So again we'll draw this parabola. Now on this parabola, we have a point P at which we'll draw a tangent, and we'll draw tangent at another point Q. So this point, it is suppose P, and this point, it is Q. Let P be a T1 square twice a T1 and Q be a T2 square twice a T2, and they intersect at point T, and we know that this point is a T1 T2 and a T1 plus T2. Now first part is, it says this TP and TQ, they subtend equal angles at focus S. We need to prove that this TP and TQ, they subtend equal angles at focus S. So basically this angle must be equal to this other angle. Now we'll write slope of SP. So slope of SP basically will be 2AT1 upon AT1 square minus A. So it will be 2T1 upon T1 square minus 1, and slope of ST, it will simply be A T1 plus T2 upon A T1 T2 minus 1. So A again will cancel. We'll get T1 plus T2 upon T1 T2 minus 1. Now we'll find this angle, say tan theta 1. So tan theta 1 will be M2 minus M1, which in this case is T1 plus T2 upon T1 T2 minus 1 minus 2T1 upon T1 square minus 1 upon 1 plus M1 M2. So it will be 2T1 T1 square minus 1, and it is T1 plus T2 upon T1 T2 minus 1. So we'll simplify. We'll get this as T1 cube minus T1 plus T2 T1 square minus T2 minus 2 T1 square T2 plus 2T1, and here it will be T1 cube T2 minus T1 square minus T1 T2, and then plus 1 and plus 2 T1 square plus 2 T1 T2. Now here we have minus T1 and plus 2 T1, and we also have T2 T1 square and minus 2 T2 T1 square. So we can write this as T1 cube plus T1 and then minus T1 square T2 and minus T2, and in the same way in the denominator we'll write it as T1 cube T2 plus T1 square plus T1 T2 and then plus 1. Now in the numerator we'll take these two terms together and these two terms together. Now here we'll take T1 common, so we'll write T1, and this is T1 square plus 1, and here we'll take T2 common, so again we'll get T1 square plus 1, and in the denominator we'll take this common, so we'll take T1 T2 common, we'll get T1 square plus 1 and plus T1 square plus 1. Now T1 square plus 1 will cancel, so then we can write tan theta as T1 minus T2 upon 1 plus T1 T2. Now basically this angle, it is symmetrical in terms of T1 and T2. So in the same way we'll write this angle for this cube taking T2, we'll end up getting this symmetric expression in terms of T1 and T2, which clearly indicates that these two angles, they must be equal. Now second result is we need to prove that this ST square is equal to SP into SQ. Now SP is nothing but A plus A T1 square and SQ is A plus A T2 square. So we'll find SP into SQ will simply be A square 1 plus T1 square into 1 plus T2 square. Now we'll write ST. Now ST square is distance between S and T. So it'll simply be A square 1 minus T1 T2 square and then plus A square, and this is t1 plus t2 whole square. So we'll take a square common and then we can write 1 plus t1 square t2 square minus 2 t1 t2, and here it will be t1 square plus t2 square plus 2 t1 t2, so we'll cancel. So we can write a square and we'll take 1 plus t square, and here we'll take t2 common. So we can write 1 plus t1 square into 1 plus t2 square. Basically it is sp into sq. So from here we can say st square is equal to sp into sq. Now this third result is this triangle SPT and STQ, they are similar. Now from here we can write ST square equals SP into SQ. So we can write ST upon SP is equal to SQ upon ST, so which is condition of similar triangles. So if ratio of sides is same, then the triangles are similar. If tangents at point Q and R intersect at P, and if P1, P2 and P3 are length of perpendiculars from P, Q and R on any tangent to parabola, then we need to prove that P2, P1 and P3, they are in GP. So we have points Q and R which lie on parabola. So suppose our parabola is y square equals 4ax, and let this point Q be at1 square twice at1, and let this R be at2 square twice at2, and we know that their point of intersection will be at1 t2 and at1 plus t2. Now we'll consider any general tangent to this parabola. So equation of any general tangent is ty equals x plus at square. So we can write this equation as x minus ty plus at square equals 0. Now we need to find length of perpendiculars from P, Q and R. So first we'll find length of perpendicular from P, and it is P1. So P1 will be, so we'll put the value of x, so it is a t1 t2 minus t a t1 plus t2 plus at square upon under root of 1 plus t square. Now P2 is perpendicular from Q. So we'll find P2. So P2 simply will be, so we'll put the value of x as at1 square and y as 2at1. So it will be at1 square minus t and 2at1 plus at square upon under root of 1 plus t square. Now we'll take this a common, then we can write this as t1 square minus 2t1 t2 plus t square upon under root of 1 plus t square. So basically value of P2 is a t1 minus t whole square upon under root of 1 plus t square. Now similarly we can say P3 should be a t2 minus t whole square upon under root of 1 plus t square. Now we'll need to prove that P2, P1 and P3, they are in GP. So we'll find P2 into P3. So P2 into P3 will be a square, and it is t1 minus t whole square into t2 minus t whole square upon 1 plus t square. So we can write this as a, and we'll multiply. We'll get t1 t2 minus t t1 plus t2 and plus t square whole square upon 1 plus t square, and which is nothing but p1 square. So we can say that P2, P1 and P3, they are in GP. So P2, P1 and P3, they are in geometric progression. Now our next result is tangents and normal at the extremities of lattice rectum of a parabola y square equals 4x constitute a square. Now we know that endpoints of lattice rectum are a, 2a and a, minus 2a, and for endpoints of lattice rectum value of t is plus or minus 1. Now we'll write equation of tangent at any point t equation of tangent at any point t is ty equals x plus at square. Now if we'll put t as plus 1, we'll get this tangent as y equals x plus a, and if we'll put t as minus 1, we'll get minus y equals x plus a. Now we'll solve these two, we'll get y as 0 and x equals minus a. So tangents at endpoints of latest rectum, they intersect at minus a comma 0, which essentially is base of directrix. Now we'll write equation of normal. Equation of normal is y plus tx equals at cube plus 2at. Now we'll put t as 1, we'll get y plus x equals 3a and y minus x equals minus 3a. Now we'll add them, we'll get y equals 0 and then x as plus 3a. So point of intersection of normals is 3a comma 0. So now we have 4 vertices. Minus a comma 0, 3a comma 0, and this is a comma 2a, and this is a comma minus 2a. Now diagonals are perpendicular and the length of two diagonals is 4a. So which clearly illustrates that these tangents and normals, they form a square and their point of intersections are minus a comma 0 and 3a comma 0. We study angle between two curves in application of derivatives, and if we are given two curves, say y equals fx and y equals gx. So what we do is we find this point of intersection, we solve the two equations by eliminating x or y, and suppose this point of intersection is x1 y1, and then we find slope of tangent to both the curves at this point P. So we'll find m1, which is dy by dx at point P for this first curve, and that will be f dash x1, and we'll find m2, which is dy by dx at point Q, and that's your g dash x1. Now once we have these two slopes, m1 and m2, we know that angle between tangents is tan theta, and it is m2 minus m1 upon 1 plus m1 m2. So when we say find angle between two curves, we essentially mean we need to find angle between either two tangents or two normals at their point of intersection. Now one more condition that is generally given in questions is conditions that two curves intersect each other orthogonally. Orthogonally means the angle between the two curves is pi by 2. So when the angle is pi by 2, then we'll have this simple condition, which is value of m1 into m2 is minus 1. Now say for example, suppose we have two parabolas, y square equals 4ax and x square equals 4ay. So we have y square equals 4ax and suppose we have x square equals 4ay. Now we need to find angle between these two parabolas at this point of intersection. So first what we'll do is we'll solve these two equations and we'll find this point of intersection. So we'll put the value of y here. So y will be x to the power 4 upon 16a square, and this is 4ax. So from here we'll get either x as 0 or x as 4a. So this point of intersection will be either 0 comma 0 or 4a comma 4a. Now we need to find angle between these two parabolas at this point of intersection P. So we'll find the slopes. So we'll differentiate this parabola. So we'll get 2y into y dash, and this is 4a. So y dash at this point P, it is 2a upon y, and y in this case is 4a. So it will simply be 1 by 2. So for this parabola, y square equals 4ax, slope of tangent is 1 by 2. Now for the second parabola, x square equals 4ay. If we'll differentiate, we'll get y dash as 2x upon 4a. So it'll simply be x upon 2a, and x here is 4a. So we'll get this value as 2. So now we have both the slopes. So this is suppose m1 and this is say m2. We can find tan theta as m2 minus m1. So 2 minus 1 by 2 upon 1 plus m1 m2, which is 1. So it'll be 3 by 4. So angle between these two parabolas at this point of intersection P is tan inverse 3 by 4. In angle between two curves, we generally have two conditions. One of it is condition of orthogonality, which we have already discussed, and another one is condition that two curves touch each other. So basically when two curves, they will touch each other, then at their point of intersection, they have a common tangent. In such cases where we need to find if two curves touch each other, all we need to do is we need to find their point of intersections and we'll find slope of derivatives m1 and m2. And if m1 is equal to m2, then we'll say these two curves, they'll touch each other. Say for example, consider the two curves y square equals 4x. So we have this parabola. Which is y square equals 4x, and then we have this circle which is x square plus y square minus 6x plus 1 equals to 0. Center is at 3, 0, and radius, it will be simply 2 root 2. So it will be some circle. Now we need to find whether these two curves, they touch each other or they'll intersect at different points. So first thing that we'll do is we'll find the points of intersection. So what I'll do is I'll eliminate this y square. So we can write this as x square plus 4x minus 6x plus 1 equals 0. So we can write this equation as x square minus 2x plus 1 equals to 0. So from here we'll get only one value of x, and that is x is equal to 1. Now we'll put x equals 1, we'll get y as plus or minus 2. So we have 2 points of intersections, say A, which is 1, 2, and B, which is 1, minus 2. Now at these point of intersections, we need to find whether these two curves, they'll touch each other or they'll just intersect each other. So at this point A, which is 1, 2, if we'll take this parabola, y square equals 4x. So we'll differentiate, we'll get y dash as 2 upon y, and y here is 2. So for this parabola, slope is 1. And for this circle, we'll get 2x plus 2y into y dash minus 6 equals 0. So now we'll put the value of x and y. X here is 1 plus 2y dash minus 3 equals 0. So from here also we'll get y dash as 1. So that means these two curves, they'll touch each other at this point A. Now in the same way, at point B, we can show that y dash is minus 1 for parabola, and in the same way it'll be minus 1 for this circle. So that means these two curves, they'll touch each other at exactly 2 points, and that's your option number B. Now in this video we'll discuss length of subtangent and subnormal in case of a parabola. So we have this parabola which is y square equals 4ax. Now at any point P, say 80 square 280, if we'll draw a tangent which intersects x-axis at point T, and we'll draw normal at point P, which intersects x-axis at point N, and we'll draw perpendicular from P to x-axis, and suppose this is M, then this length Tm, it is called as subtangent, and this length Mn is called as subnormal. Now this PT is also called as length of tangent, and this Pn is length of normal. Basically, we study subtangents and subnormal in application of derivatives, but we'll discuss it here also in brief. Now, if this length is y and this angle is theta, then in this right angle triangle, we can write Tm as y upon tan theta, and tan theta is nothing but slope of tangent. So length of subtangent, we can write it as y upon dy by dx at any point P. So this is length of subtangent. Now in case of subnormal, which is Mn, this angle is theta, this angle here will also be theta. So in this case, it will be y into tan theta. Now it will simply be y into dy by dx at any point P. So this is how we write length of subtangent and length of subnormal for any general curve. Now for this curve, if you have to write length of tangent simply will be y square plus subtangent square. So it will be y square plus y upon dy by dx whole square, and in the same way length of normal will be y square plus length of subnormal square, which is y into dy by dx whole square. So in calculus, we find length of subtangent and subnormal using derivatives. Now here we'll find subtangent and subnormal using equations. So let this point P be 80 squared to 80. We know that equation of tangent will be Ty equals x plus 80 square. So coordinate of this point T, it will be minus 80 square comma 0, and equation of normal is y plus tx equals at cube plus 280. So in this case, coordinate of this point N, it will be 80 square plus 2a comma 0, and this point M, it is simply 80 square comma 0. Now first point is we need to show that length of subtangent is twice the abscissa of the point. So we'll find length of subtangent, which is Tm. Now Tm basically will be 80 square minus of minus 80 square. So it will be 2 times 80 square, and this is 2, and x coordinate here is 80 square. So it is 2 times x coordinate of P. And it also says, note that subtangent is bisected at the vertex. So this length, it is 80 square, and this length here also is 80 square. So clearly subtangent is bisected at the vertex of parabola. Now the next part is we need to show that length of subnormal is constant. So length of subnormal Mn will simply be now n minus m. So it is 80 square plus 2a minus 80 square, which is simply 2a, which is independent of t. So essentially in a parabola, length of subnormal is always constant, and it is equal to semi-latus rectum of parabola. Now let us take another question, and the question is, if the locus of centers of family of circles passing through vertex of parabola y square equals 4ax and cutting the parabola orthogonally at other point of intersection is 2y square plus x square minus 12ax, and it is equal to ax kx minus 4a whole square, we need to find the value of k. So we have this parabola, which is y square equals 4ax, and then we have this circle which passes through vertex, which is origin, and which intersects this parabola orthogonally. So we'll draw this circle, and suppose it intersects this parabola at this point P, and coordinate of this point P is say 80 square 280. Now we need to find locus of center of this circle. So since it is a locus problem, first step is identify the point. So let the center be say H, K. Now it is given that these two curves, they intersect each other orthogonally. So that means angle between their tangents is 90 degrees. Now since angle between the tangents is 90 degrees, so it simply means tangent to this parabola at this point P will actually be a normal to this circle. So center of this circle will lie on tangent drawn at this point P. So for this parabola, we'll write equation of tangent. So we write equation of tangent at this point P. So at this point P, equation of tangent is given by Ty equals x plus at square. And since center of the circle will lie on this tangent, so we can write kt equals h plus at square, and we'll write it as a quadratic equation in t. So we can write this as at square minus k into t plus h equals to 0, and that's our first equation. Now we'll get the second result from the fact that distance of these 2 points from the center must be same. So basically OC must be equal to OP. Now OC is h square plus k square, and OP will be h minus at square whole square plus k minus 2at square. Now here h square k square will cancel. So here we'll get a square t to the power 4 minus 2ah t square, and then plus 4a square t square and minus 4a t into k equals 0. Now here we can take at common. So if we'll take at common, then we'll get this equation as at cube, and plus here we'll get 4a minus 2h into t and minus 4k equals 0. So we'll get this equation as at cube plus 4a minus 2h t minus 4k equals 0. Now we'll need to eliminate this t. So what we'll do is we'll take this at square and we'll put the value of at square in this first expression. So we'll take this t common, and then we'll write at square as kt minus h. So it'll be kt minus h plus 4a minus 2h into t minus 4k equals 0. So we can write this equation as kt square. Now this is minus h into t minus 2h into t. So we'll write it as 4a minus 3h into t minus 4k equals 0. And that's our second equation. Now we need to eliminate t from these two equations. Now basically what we'll do is we'll assume these two equations as linear equation in t square and t. So we can solve these linear equations. So we can write t square, and this is b1 b2. So it'll be minus k, and here it is 4a minus 3h, and then c1 c2. It will be h and minus 4k, then h and minus 4k, and here it will be a and k, and first it will be ak, and then it will be minus k 4a minus 3h. So we can write this as t square upon 4k square minus 4ah plus 3h square, and this is t, this is h into k plus 4ak and here it will be 4a square minus 3ah plus k square. Now we'll equate these first two expressions. We'll get t as 4k square minus 4ah plus 3h square upon h plus 4a into k, and from this second and third expression we'll write h plus 4a into k, and this is equal to 4a square minus 3ah plus k square. So this is our required locus, but then we'll have to put it in the form which is given in the question. So we need to cross multiply. So we'll cross multiply, we'll get 16 a square k square minus 12 ah k square plus 4k to the power 4 minus 16 a cube h plus 12 a square h square minus 4ah k square, and then plus 12a square h square minus 9ah cube plus 3 h square k square, and it is equal to k square, and this is h square plus 16a square plus 8ah. Now from these two sides, 16a square k square and 16a square k square will cancel. Now we'll take terms of k together. So it will be 4k to the power 4, and then we'll have minus 12ah k square minus 4ah k square. Then we'll have 3h square k square and h square k square. So it will be plus 2 h square k square, and then we'll have minus 12ah k square minus 4ah k square and minus 8ah k square. So there'll be minus 24 ah into k square. Now whatever remains, we'll take it on right hand side. So we'll have 16 a cube h plus 12a square h square and 12a square h square. So it will be minus 24 a square h square and then plus 9 a h cube. Now here what we'll do is here we'll take 2k square common. So if we'll take 2k square common, we'll get 2k square plus h square minus 12ah, and here we'll take ah common. So we'll take ah common, we'll get 16a square minus 24ah plus 9h square. So this is 2k square plus 2k square plus h square minus 12ah, and this is ah, and it will be 3h minus 4a whole square. Now in the end, we'll replace h with x and k with y. So we can write this locus as 2y square plus x square minus 12ax, and this is ax, and 3x minus 4a square. So 2y square plus x square minus 12ax, ax, and 3x minus 4a whole square. So we need to find value of k, and k obviously in this case is simply 3. So value of k is 3, and that is the answer to this question.
Now the next question is, let P be a point of intersection of common tangents to parabola y square equals 12x and hyperbola 8x square minus y square equals 8 if S and S dash denote the foci of hyperbola where S lies on positive x-axis and P divides S dash in the ratio. Now first what we'll do is we'll find point of intersection of common tangents, and before that we'll need to find these common tangents. So equation of tangent to this parabola, it will be y equals mx plus a by m. A in this case is 3, so it will be y equals mx plus 3 by m. And for this hyperbola, which is x square upon 1 minus y square upon 8 equals 1, equation of tangent will be y equals mx plus minus under root of a square m square minus b square. Now both the lines, they represent the same tangent. So from here we'll get this condition that 3 by m is equal to under root of m square minus 8. So we'll square it, we'll get m to the power 4 minus 8m square minus 9 equals 0. So the condition will be m square minus 9 into m square plus 1 equals 0. That is, the value of m is plus or minus 3. Now we'll put the value of m as 3. We'll get this equation as y equals 3x plus 1. And if we'll put m as minus 3, we'll get this equation as minus 3x minus 1. Now we'll need to find their point of intersection. Now we'll add them. We'll get y equals to 0. And if we'll put y equals 0, we'll get x as minus 1 by 3. So this point P, it will be minus 1 by 3, comma 0. Now we need to find S and S dash, which are foci of this hyperbola. Now for this hyperbola, first we'll find eccentricity. So we know that B square is A square into E square minus 1. Value of E here is 3 and A is simply 1. So foci are at plus minus AE comma 0. So it will be plus minus 3 comma 0. So one of the focus is at 3 comma 0 and the other one is minus 3 comma 0. S lies on positive x-axis and S dash will be on negative x-axis. Now we'll need to find this ratio SP upon S dash P. Now SP will be 3 minus 1 by 3 and there'll be 3 minus minus plus 1 by 3 and there'll be 10 by 3 and here it will be minus 1 by 3 plus 3 and it will be 8 by 3. So this ratio SP upon S dash P, it will be 10 by 8, which is 5 by 4, and that's your option number C. Now here the question is, find the equations of common tangents of the two given hyperbola. The first hyperbola is x square upon a square minus y square upon b square equals to 1. And we know that for hyperbola of the first form, equation of tangent is y equals mx plus minus under root of a square m square minus b square. Now second hyperbola is hyperbola of the second form, which is y square upon a square minus x square upon b square equals to 1. And we have already studied that for this hyperbola, equation of tangent is y equals to mx under root of a square minus b square m square. Now these two equations, they represent the same tangent. So it simply means that this constant term, it must be same. From here we'll get this condition, which is a square m square minus b square must be equal to a square minus b square m square. Now we'll take everything on the left hand side. We'll get a square into m square minus 1 plus b square into m square minus 1 equals to 0. So the condition that we'll get is a square plus b square into m square minus 1 equals 0. That is, the value of m should be plus 1 or minus 1. Now we'll put m as plus minus 1. We can write equation of tangent as y equals plus minus x plus minus under root of a square minus b square. And that's your option number 1. Now we'll discuss some questions on common tangents, as they are very important in conic sections. Now the first question is, a straight line touches the rectangular hyperbola 9x square plus 9y square equals 8 and the parabola y square equals 32x. We need to find the equation of this line. Now we know that for a hyperbola, equation of tangent is y equals mx plus minus under root of a square m square minus b square. Now in this case, a and b, they're both same and it is 8 by 9. So it will be 8 by 9 m square minus 1. And in case of a parabola, equation of tangent is given by y equals mx plus a by m. And a in this case is simply 8. So it will be 8 by m. Now these two equations, they represent the same line. So from here we can write 8 by 9 m square minus 1. It must be equal to 8 square upon m square. Now here 8 and 8 will cancel. So we'll get this result as m to the power 4 minus m square minus 72 equals 0. And there will be m square minus 9 m square plus 8 equals 0. So value of m must be plus or minus 3. Now we'll take plus sign. Then this equation will be y equals 3x plus 8 by 3, which is 9x minus 3y plus 8 equals to 0. And that's your option number B. And if we'll take m as minus 3, then we'll get this equation as y equals minus 3x minus 8 upon 3. In that case, equation will be 9x plus 3y plus 8 equals to 0. And that's your option number C. So answer to this question is options B and C. Now here the question is, let a, b and lambda be positive real numbers. Suppose p is one end of latest rectum of parabola y square equals 4 lambda x, and suppose the ellipse x square upon a square plus y square upon b square equals 1 passes through the point P. The tangents to the parabola and ellipse at point P are perpendicular to each other. Then eccentricity of ellipse is. Now for this parabola, this point P is end point of latest rectum. So we know that end points of latest rectum for parabola is a comma 2a. So we'll write this as lambda comma 2 lambda. Now it says this point P, it also lies on this ellipse. So we'll get this condition that lambda square upon a square plus 4 lambda square upon b square, and it must be equal to 1. Now it says the tangent to the parabola and ellipse at point P are perpendicular to each other. Now we know that equation of tangent to parabola at this given point P is given by t equals 0. So this equation will be 2 lambda y equals 4 lambda and then x plus lambda by 2. So here 2 lambda will cancel. So we'll get this equation as x minus y plus lambda equals 0. And equation of tangent to this ellipse will be lambda x upon a square plus 2 lambda y upon b square, and it is equal to 1. So again, it is given by t equals 0. Now slope of this tangent to parabola is 1 and slope of tangent to this ellipse is minus b square upon 2a square. Now it is given that these two tangents, they are perpendicular. That means product of slope is minus 1. So we'll write m1 into m2 as minus 1. We'll get minus b square upon 2a square equals minus 1. Now here minus and minus will cancel, and b square is a square into 1 minus e square, and it is equal to 2a square. Now we are not getting any result from this condition. So it simply means that this ellipse must be of the second form. So we'll assume it for the second form. Then we can write b square will be 2, and we can write a square as b square into 1 minus e square. Now this b square will cancel. We'll get 1 minus e square equals 1 by 2. Value of e should be 1 by root 2, and that's your option number A. Question number E is, a line is tangent to the parabola y equals x square. So we'll draw this parabola. Now we are given a point a comma a square.
And we have drawn a tangent at this point. Now we'll need to find area of this region. Now before that, we'll find equation of this tangent. We know that equation of tangent is given by t equals 0. So we can write this y as y plus a square upon 2 and then ax. Now we need to find this point of intersection with x-axis. So for x-axis, we'll put y as 0, and if we'll put y as 0, we'll get x as a by 2. So this point is a by 2 comma 0. Now in order to find this area, what we'll do is we'll find area of this parabola with the x-axis, and then we'll subtract area of this right angle triangle. So this area will be this integral from 0 to a y dx, which is x square dx, and then minus 1 by 2. Length of the base is a by 2 and height is a square. So this value will be a cube by 3 minus a cube by 4. So this area will be a cube by 12, and that's your option number C. Now here the question is common tangents to the circle x square plus y square equals 2, and this parabola y square equals 8x. They touch the circle at P and Q and parabola at R and S. So these tangents, they touch the circle at points P and Q and parabola at R and S. And it says find the area of this quadrilateral PQ RS. Now we can write equation of tangent to this circle, and it is given by y equals mx plus minus r under root 1 plus m square, and for this parabola it is given by y equals mx plus a by m, and a in this case is 2, so it will be this 2 by m, and we are talking about common tangent, so it will have same slope and same equation. So from here we can write plus minus root 2 under root 1 plus m square will be equal to 2 by m, so it will be this root 2, and we square it, we can write m to the power 4 plus m square minus 2 equals 0, or m square plus 2 into m square minus 1 equals to 0. So value of m is plus or minus 1. So equation of one of the line is y equals x plus 2, and equation of this other tangent is y equals minus x minus 2. Now we have to find this point of contacts P and Q. Now suppose this P is x1 y1, then equation of tangent to this circle will be given by x1 plus y1 minus 2 equals 0, and we'll compare it with this x minus y plus 2 equals 0. So from here we get x1 upon 1 y1 upon minus 1, it is equal to minus 1. So this point of contact is at minus 1 comma 1. So this P is minus 1 comma 1, and this Q is minus 1 comma minus 1. For this parabola, we know that point of contact, it is given by a by m square and 2a by m. Now in this case, a is 2 and m is 1. So it will be this 2 comma 4. So coordinate of R is 2 comma 4, and this coordinate will be 2 comma minus 4. Now we have to find area of this trapezium. Now area of this trapezium, it is given by 1 by 2 sum of parallel sides. Now this is 2 and this is 8. So there will be 10 into this perpendicular, and this perpendicular is simply 3. So this area is 15 square units. So the correct option is this option D. Now here the question is, let R and S be the diameter of the circle where S is this point 1, 0. Let P be a variable point other than RS on the circle, and tangents to the circle at S and P meet at point Q. The normal to the circle at P intersects a line drawn through Q parallel to RS at point E. Then locus of E passes through which of the following point? So we have this circle with center at origin, Now this point S, it is 1, 0. Then basically this point R, it is minus 1, 0. Then we have a variable point P on this circle, and suppose this P is cos theta, sin theta. Now equation of tangent is given by t equals 0. So we'll get this as x cos theta plus y sin theta equals to 1. So it has this tangent, and it says tangent to the circle at S and P meet at this point Q. So if we draw a tangent at this point S, these two tangents, they meet at this point Q. Now tangent at S, it is simply x equal to 1. So coordinate of this point Q will be 1, 1 minus cos theta upon sin theta. Now 1 minus cos theta is 2 sin square theta by 2, and this is 2 sin theta by 2 cos theta by 2. So we can also write this as 1, tan theta by 2. Now it says the normal to the circle at P intersects the line drawn through Q parallel to RS at point E. So normal through P intersects a line drawn through Q parallel to RS at point E. So we have drawn a line at this point Q, and this line is y equals tan theta by 2, and it intersects at this point E, and we have to find locus of E. So this point is alpha, beta. Now if we write equation of OP is simply y equals tan theta x. Since this line is parallel to x-axis, its y coordinate is tan theta by 2, so we can write beta as tan theta by 2, and alpha will be beta upon tan theta, so there will be tan theta by 2 upon tan theta. Now first we have to find locus of this point E. Now beta is tan theta by 2, so we can write beta upon alpha as tan theta, and tan theta is 2 tan theta by 2 upon 1 minus tan square theta by 2. Now tan theta by 2 is beta, so we can write this as beta upon alpha, and this is 2 beta upon 1 minus beta square. Now this beta square will cancel, so this locus will be 1 minus beta square equals 2 alpha. We'll replace beta with y and alpha with x, then we can write y square equals 1 minus 2x, which is a parabola. So locus of this point E, it is this parabola, y square equals 1 minus 2x. Now it says which of the 4 points will lie on this parabola. Now we look at this point A, its coordinate is 1 by 3 under root 1 by under root 3. So if we put y as 1 by root 3 will be this 1 by 3, and 1 minus 2 by 3, it satisfies this equation. So this option A is correct. Now for this option B, we have 1 by 4 and 1 by 2. So this is 1 by 4 and this is 1 minus 1 by 2, not equal. So this option B is incorrect. Point C is 1 by 3 minus 1 by root 3. So this is 1 by 3 and 1 minus 2 by 3, which again is true. So option C is correct. And then this option D, where we have 1 by 4 and minus 1 by 2. So it will be this 1 by 4, 1 minus 1 by 2. This is incorrect. So the correct options are A and C. Now the question is, let P be a point on parabola y square equals 4x, which is at a shortest distance from the center of the circle. And we have this circle whose center is at 2, 8 and its radius is 2 units. Let Q be the point on the circle dividing the line segment SP internally. Then, which of the following options is or are true? So we have this parabola, y square equals 4x, and then we have this circle which is at 2, 8 and radius equals 2 units. Now point on this parabola which is at a shortest distance from this circle will be along this common normal. So what we'll do is we'll write equation of normal to this parabola, and we know that equation of normal is given by y plus tx equals 2at plus a t cube, and in this case value of a is 1, so it will be this y plus tx equals 2t plus t cube, and this normal will pass through center of the circle, so it will be this 8 plus 2t equals 2t plus t cube. Now this 2t will cancel, so value of t is simply 2. So coordinate of this point P will be at square. A is 1 and t is 2, so it will be this 4 comma 2at. So this point is 4 comma 4. So we have this S which is 2 comma 8, and this point it is Q. Now if we find SP is under root of, now 4 minus 2 square is 4 plus 8 minus 4 square is 16, so it will be this root 20, and root 20 is 2 root 5. That means this option A, it is correct. Now radius is 2, that means SQ is 2, then QP will be SP minus SQ, so there will be 2 root 5 minus 2, so this ratio SQ upon QP will be 1 upon root 5 minus 1. If we rationalize it, we'll get this as root 5 plus 1 by 4. That means this option B is incorrect. Now C is x-intercept of the normal to the parabola at P is 6. Now we know that T is 2, so equation of normal will be y plus 2x, and that will be equal to 4 plus 8, 12, and for x-axis intercept we'll put y as 0, we'll get x as 6. So we'll intersect x-axis at 6, 0. That means this option C is also correct. And D is slope of tangent to the circle at Q is 1 by 2. Now basically this PS is normal, slope of this line is minus 2, then slope of tangent will be 1 by 2. That means this option D is also correct. So the correct options are A, C and D. Now in this question we are given 3 columns, and then we have to answer the 3 questions. We know that column 1, column 2 and column 3 are obviously related. So we are going to join these columns. Now this is parabola y square equal to 4ax. Now its tangent is y equal to mx plus a by m. So this third, it is connected with 1, and point of contact is at square 2at. It will be this 3 1p. Now x square upon a square plus y square equals to 1. This is ellipse, and equation of ellipse is given by y is equal to mx plus minus under root a square m square plus b square. So that means the second, it matches with 4, and its point of contact will be this r. For this circle, equation of tangent is y is equal to mx plus minus r under root 1 plus m square, and the point on the circle is minus maa. So this first, it matches with second, it matches with q, and this hyperbola, it matches with third, and it matches with s. So these are the possible combination for the 4 given curves. Now this first question is the tangent to a suitable conic at this point, say a, root 3 comma 1 by 2, it is root 3x plus 2y equals to 4. So here we have this conic and tangent at root 3, 1 by 2 will be drawn like this. Now for parabola and hyperbola, tangent will have positive slope. So it cannot be a parabola or a hyperbola. So it can only be a circle or an ellipse. But in case of a circle, equation of tangent will be x(x1) plus y(y1) equals a square, where point of contact is x1, y1. So in that case, this equation will be root 3x plus 1 by 2y. So it cannot be this circle. So it has to be this ellipse. So this point, it should lie on ellipse. So answer should be second, fourth and R. That's your option D. Now we'll prove it also. Now if we have this point will lie on this ellipse. So we'll get 3 plus a square by 4 equals a square. So value of a square is 4. That means value of a is 2. So equation of this ellipse will be x square plus 4y square equals to 4. Now equation of tangent is given by t equals 0. So there will be root 3x plus 4 into 1 by 2y equals 4. So it will be this root 3x plus 2y equals 4, which is this given option. Now we have to verify this point of contact. This minus a square m. So this is minus 4m is minus root 3 by 2 upon under root of a square m square plus 1. And this is a square m square plus 1. Now this is root 3 comma 1 by 2. So that means this one, it matches with D. Now the second one is, if tangent to a suitable conic is found to be y equals x plus 8 and the point of contact is 8, 16, then which of the following option is the correct combination? Now in this case, it has to be either this parabola or this hyperbola. So for this second question, we know that this point is 8, 16 and it is y equals x plus 8. Now in this case, value of m is 1 and this parabola is y square equals 4ax. So first we'll check for this parabola. Now this is 16 square and this is 16 into 2. So value of a is 8. And we know that equation of tangent is given by y equals mx plus a by m. That means this is the equation of tangent, and point of contact, it is given by a upon m square and 2a upon m. So it will be this 8, 16, which is this given condition. So it will be this parabola. Third, it connects with 1 and p. So it will be 3, 1p. And that's your option A. And the next one is, for a equals root 2, if a tangent is drawn to a suitable conic at the point of contact minus 1, 1, then which of the following option is the only correct combination for obtaining its equation? Now if we put x as 1 and y as 1, then we should get a as root 2. This is only possible in this case of a circle. So this third one, it should be this 1, 2 and q. And that's your option D. Now in this case, since a is root 2, equation of this circle is x square plus y square is root 2. Point of contact is minus 1, 1. Equation of this line is x plus y equals to 2. And value of m is 1. And if we put a as root 2 and m as 1, so here root 2 will cancel. So this is minus 1, 1, which is a given point. So the correct options are D, A, D. Now the question is, consider parabola y square equals 4x. Now we have this parabola And then it says we have this point P minus 2, 1. And from this point, tangents are drawn to this parabola. Which touches parabola at points P1 and P2. Now, focus of this parabola is S, and in this case, A is 1. So, focus is at 1, 0. Now, it says, we join these SP1 and SP2. Now, Q1 and Q2 be points on lines SP1 and SP2 such that PQ1 is perpendicular to SP1. So, from here, we have dropped perpendiculars. This point is Q1. And from here, this perpendicular is Q2. Now, which of the following is or are correct? Now, what we'll do is we'll take points P1 and P2 in terms of parameter coordinates. Now, P1 is 80 square 280 and A is 1. So, this is T1 square 2T1 and P2 is T2 square 2T2. And we know that point of intersection of tangents is given by A T1 T2 and A T1 plus T2. Now, A is 1. So, this is T1 T2 and T1 plus T2. So, from here we can say P1 into T2 is minus 2 and T1 plus T2 is 1. Now, from here we'll put the value of T2. T2 is 1 minus T1. So, it will be T1 and then 1 minus T1 equals minus 2, or it will be T1 square minus T1 minus 2 equals 0. We can write T1 minus 2 and then T1 plus 1 equals 0. So, from here we'll get two conditions, that either T1 is 2 or T1 is minus 1. Now, if we take T1 as 2, T2 will be minus 1. So, in this case, value of T2, it will be minus 1. And if we take T1 as minus 1, we'll get T2 as 2. So, we'll get two cases where either T1 is 2 and T2 is minus 1, or T1 is minus 1 and T2 is 2. Now, if we take T1 as 2, this is 4, 4. And if we take T2 as minus 1, this point it will be 1, minus 2. So, now we have coordinates of P1 and P2. Now, for the second one, P1 and P2, they'll interchange. So, in this case, P1 will be 1, minus 2 and P2 will be 4, 4. Now, we need to find Q1 and Q2. Now, basically, we'll find equation of this line P1S. Now, this is y minus 0 and slope of this line will be 4 by 3 x minus 1. So, this equation will be 4x minus 3y minus 4 equals 0. Now, for Q1, we'll find foot of perpendicular from this point. So, basically, it will be x plus 2 upon 4, y minus 1 upon minus 3, and this is minus. Now, this is minus 8, minus 3, minus 4 upon, and this is 25. So, it will be x plus 2 upon 4, y minus 1 upon minus 3. Now, this is 15 upon 25, and 15 upon 25 is 3 by 5. Now, this is 12 by 5 minus 2. 12 by 5 minus 10 is 2 by 5. So, in this case, value of x is 2 by 5. And here it is minus 9 by 5 and plus 1. So, there will be minus 4 by 5. So, value of Q1 will be 2 by 5 and minus 4 by 5. Now, we will find equation of SP2. Now, basically, both the coordinates, they are 1. So, its equation is simply x equals 1. So, for Q2, x coordinate is 1. Now, this line is parallel to y-axis. So, this line will be parallel to x-axis. So in this case, its y coordinate will also be 1. So value of q2 is 1, 1. Now the first one is we have to find sq1. Now sq1 is under root of, now 1 minus 2 by 5 is 3 by 5, which is 3 square by 5 square plus 4 square by 5 square, which is 1. And sq2 also is 1. So it doesn't matter whether we take first case or the second case, sq1 will always be 1. So that means this option A is incorrect. Now second one is value of q1, q2. Now q1, q2 is under root of, now this is 3 by 5 whole square. So it will be 9 by 25 plus, and this is 1 plus 4 by 5, 9 by 5. So it will be 81 by 25. So it is 90 by 25 and it will be 3 under root 10 by 5. That means this option B is correct. Now if we look at PQ1. PQ1 will be 2 by 5 plus 2. So there will be 12 by 5 whole square, 144 by 25 plus 1 plus 4 by 5, and there will be 81 upon 25, and it will be 225 upon 25, which is 9. So this value is simply 3. So that means this option C is also correct. Now SQ2, S is 1, 0, Q2 is 1, 1, then clearly SQ2 is 1. That means this option D is correct. So the correct options are B, C and D. Now here the question is, tangents are drawn to the parabola y square equals 4x from the point 6, 5 to touch the parabola at Q and R. Now it says if C1 is a circle which touches the parabola at Q and C2 is a circle which touches the parabola at R, both the circles C1 and C2, they pass through focus of parabola. Then we have to solve this question. Now here we have this parabola y square equals 4x, and then from a point P 6, 5 we have drawn two tangents which touch this parabola at Q and R. So what we'll first do is we'll find the Q and R. Now we know that for this parabola y square equals 4x, value of A is 1, then equation of tangent is given by Ty equals x plus a t square. So in this case it will be Ty equals x plus t square. Now we need this tangent which passes through this point 6, 5. So we'll put x as 6 and y as 5. So we'll get t square minus 5 plus 6 equals 0. So here the value of t will be either 2 or 3. So coordinate of this point Q will be 80 square 280, which is 4, 4, and for this point R it will be 80 square 9 and 280 is 6, 9, 6. So the 2 points are 4, 4 and 9, 6. Now this first question is find the area of this triangle PQR. Now we know that area of triangle is given by 1 by 2 x1 y1 1. So it will be this 6, 5, 1, 4, 4, 1 and 9, 6, 1. Now we subtract first from third. It will be this 3, 1, 0, and the second from first, then it will be this minus 2, minus 1, 0, and then it will be this 6, 5, 1. Now we expand it, we'll get this as minus 2 plus 3. So this is 1 by 2. So value of this area is 1 by 2, and that's your option A. So area of triangle PQR is this option A. Now the second one is radius of circle C2. Now it says we have two circles C1 and C2 which pass through focus of parabola, which is at 1, 0 and which touch these points. So this point is 1, 0 and then we have this circle. We have to find radius of this second circle C2. Now for this C2, what we'll do is we'll write equation of this tangent PR. And for our value of t is 3, so if we put 3 here, we'll get equation of PR as 3y equals x plus 9. Or this equation is x minus 3y plus 9 equals 0. Now we can find equation of family of circles touching this line at this point 9, 6. So equation of family of circles will be given by x minus 9 square plus y minus 6 square plus lambda and then x minus 3y plus 9 equals to 0. Now this circle, it passes through focus. So it will pass through 1, 0. We'll put x as 1 and y as 0. If we put x as 1, we'll get this as minus 8 square 64 and y is 0. So it will be this 6 square 36 plus lambda 1 plus 9 equals 0. Now this is 110. So value of lambda is minus 10. So we can write equation of this circle as x square plus 81 minus 18x y square plus 36 minus 12y minus 10x plus 30y minus 90 equals 0. So this equation will be x square plus y square minus 28x plus 18y plus 27 equals 0. Now center of the circle is at 14, minus 9 and its radius will be 14 square plus 9 square minus 27, which is under root 250, which is 5 root 10. So radius of this second circle is 5 root 10 and that's your option B. And the next part is the common chord of the two circles passes through which of the following center of this triangle PQR. And for this again we have to find equation of the circle C1. For circle 1, equation of tangent will be given by 2y equals x plus 4 or x minus 2y plus 4 equals 0. And this point of contact is 4, 4. We can write this equation as x minus 4 square plus y minus 4 square plus lambda x minus 2y plus 4 equals 0. It will pass through 1, 0. So this is 9 plus 16 plus lambda plus 5 equals 0. So value of lambda is minus 5. So we'll get this equation as x square plus y square plus 16 minus 8x plus 16 minus 8y minus 5x plus 10y minus 20 equals 0, or it will be this x square plus y square minus 13x plus 2y plus 16 equals 0. Plus 12 equals 0. Now once we have equation of both the circles, we can find equation of their common chord, which is basically their radical axis. So it will be 28 minus 13 minus 15x 18y minus 2y plus 16y, and 27 minus 12 is 15. So this equation of common chord is minus 15x plus 16y plus 15. So equation of common chord is given by minus 15x plus 16y plus 15 equals 0. Now, which of the point is going to pass through this common chord? Now, easiest one is centroid. So first we'll find its centroid. Now, centroid is given by 6 plus 4, 10. 10 plus 9, 19. So it will be this 19 by 3. And then we have 15 by 3, which is 5. So we put this, we'll get this as 5. So it will be minus 19 into 5 plus 80 plus 15. So it is minus 95 plus 95, which is 0. That means centroid is going to lie on this common chord. So it will pass through centroid of this triangle, and that's your option C. The correct options are A, B and C. Now the question is, tangents are drawn at any point x1, y1 other than vertex of the parabola, then if tangents are drawn from any point on this tangent to the circle such that all the chords of contact pass through a fixed point x2, y2, then which of the following is correct? Now in this question, this point x1, y1, it lies on this parabola, and we know that equation of tangent, if the point lies on the curve, it is given by t equals 0. So equation of this tangent will be given by y, y1 4a x plus x1 by 2. So it will be this 2ax minus y1 plus 2ax1 equals 0. Now suppose a point on this tangent is this point P, which is h comma k, so we'll get 2ah minus y1k plus 2ax1 equals 0, and that's our first equation. Now from this point, if we write equation of chord of contact to this circle, x square plus y square equals to a square, we know that chord of contact is given by t equals 0. So we'll get this equation as hx plus ky, and it is equal to a square, and it says the chord of contact will pass through this fixed point x2, y2. So we can write hx2 plus ky2, it is equal to a square. Now these two equations, they represent the same line. So we'll have 2ah minus y1k plus 2ax1 equals 0. So from here we can write 2a upon x2 will be equal to minus y1 upon y2 2ax1 upon minus a square. Now if we take these first two conditions, then we can write x1 x2 equals minus a square. That means this option A, it is incorrect. So x1 a x2, they cannot be in GP. Now we also know that this point x1 y1, it lies on this parabola. So we have y1 square is equal to 4a x1. So if we solve these first two, we can write minus x2 y1, it is equal to 2a y2
Now we'll multiply this with y1. So we'll write minus x2 into y1 square, and this is 2a y1 y2. Now y1 square is 4a x1. So this is minus 4a x1 x2, and this is 2a y1 y2. Now x1 into x2 is minus a square. So here it will be y1 y2, it is equal to 2a square. Now we can rearrange this as y1 upon 2 into y2, it is equal to a square. That is y1 by 2, y2 and a, they are in GP. So this is your option B. And if we add x1 x2 and y1 y2, we'll get x1 x2 plus y1 y2 will be minus a square plus 2a square. That should be a square, and that's your option D. Now what about this option C? Now for the C part, we'll take these two. So we'll have 2a equals minus x2 y1 upon y2, and if we take these two, then we'll have a by 2 equals x1 y2 upon y1. Now we'll put the value of a in this, then we can write 2 times, and this a is 2 x1 y2 upon y1, and it will be equal to minus x2 y1 upon y2. Now we can write this as y1 upon y2 whole square, and this is minus 4 x1 upon x2, which is minus 4 y1 upon y2 and x1 upon x2. They are in GP. That means this option C is also correct. So the correct options are B, C and D.
Question number E is, a line is tangent to the parabola y equals x square. So we'll draw this parabola. Now we are given a point a comma a square, and we have drawn a tangent at this point. Now we need to find area of this region. Now before that, we'll find equation of this tangent. We know that equation of tangent is given by t equals 0. So we can write this y as y plus a square upon 2 and then ax. Now we need to find this point of intersection with x-axis. So for x-axis, we'll put y as 0, and if we'll put y as 0, we'll get x as a by 2. So this point is a by 2 comma 0. Now in order to find this area, what we'll do is we'll find area of this parabola with the x-axis, and then we'll subtract area of this right angle triangle. So this area will be this integral from 0 to a y dx, which is x square dx, and then minus 1 by 2. Length of the base is a by 2 and height is a square. So this value will be a cube by 3 minus a cube by 4. So this area will be a cube by 12, and that's your option number C.
Today we'll solve a question which I have previously solved, but then that solution was fairly elaborate and comprehensive and rather too long. We'll discuss a shorter method to solve the question today. Now the question was, consider the parabolas y minus 2 whole square equals 4x minus 2 and x minus 2 whole square equals 4y minus 2, and let S be the largest circle touching the two parabolas internally in the bounded region. Find the center and radius of the circle. We have already drawn the two parabolas. This pink parabola is x minus 2 whole square equals 4y minus 2, and this parabola in blue is y minus whole square equals 4x minus 2, and we have to find center and radius of this largest circle touching the two parabolas internally in the bounded region. Now in order to simplify the problem, what we'll do is we'll shift the origin and we'll let capital X as x minus 2 and capital Y as y minus 2. So now our two equations are capital Y square equals 4x and capital X square equals 4y, which are standard equations. So basically we have shifted the origin to 2, 2, and now this is our new origin, and the equation we have is y square equals 4x and x square equals 4y. We need to find center and radius of this circle. Now if we solve these two equations, we already know their point of intersections are 0, 0 and 4, 4, and y square equals 4x and x square equals 4y. They are inverse image of each other. So basically they are reflection of each other about y is equal to x line. So the two parabolas, the reflection of each other about y equals x line. From symmetry we can say that center of this circle, it will lie on this line, and suppose this center is h, h. Now if this circle is the largest circle, then what it will do is it will touch the two parabolas at the end point of diameter. So these point of contacts, say A and B, they will be end points of diameter. Now suppose this A is x1, y1, then from symmetry this B, it will be y1, x1. It's just reflection of A about y equals x line. And since AB is diameter, that means tangent at A will be parallel to this given line y equals x. So that means dy by dx at A, it must be equal to slope of this line y equals x, which is 1. This A, it lies on this curve, y square equals 4x. So we differentiate, we'll get 2y dy by dx, and it is equal to 4. So dy by dx, it is equal to 2 upon y1, and this is equal to 1. So from here we can get y1 equals 2. Now if we put y1 as 2, we'll get x1 as 1. So value of x1 is 1. So coordinate of this point A, it is 1, 2, and from symmetry, coordinate of this point B will be 2, 1. And center of this circle, say C, it is midpoint of AB. So this point C, it will be midpoint of AB, which is 2 plus 1 by 2, and that is 3 by 2, and here also will be 3 by 2. So center of the largest circle will lie at 3 by 2, 3 by 2, and we can find its radius also. Now radius of this circle, it is basically half of diameter 1 by 2 AB. Now this is 1 by 2, and AB is under root of, now this is 2 minus 1 square 1 plus 1, so it will be simply 1 by root 2. So center of this circle, it will be at 3 by 2, 3 by 2, and its radius is 1 by root 2. But we need center of the circle for these two parabolas and not the standard parabolas. So what we'll do is, we know capital X is 3 by 2 and capital Y is 3 by 2. So we'll replace X with X minus 2. So X minus 2 equals 3 by 2 and Y minus 2 equals 3 by 2. So basically X is 7 by 2 and Y is also 7 by 2. So center of the circle, it will be at 7 by 2 and 7 by 2, and radius of this circle will be 1 by root 2. And if we have to write equation of this circle S, it will be x minus 7 by 2 square plus y minus 7 by 2 square, and it is equal to 1 by 2, and that is the answer to this question. I'll provide the link to the lengthy solution in the description below.